This is part 2 of the language features tutorial and lecture. Um, what we're going to cover in this half of the lecture is type interfaces, anonymous types, LINQ queries, and async methods. The first thing I want to talk about is type inferences. And in using type inferences, we gain a lot of flexibility with our application and how we declare variables and flexibility around changing variable types without having to go through the work of defining them explicitly. So let me give you a concrete example. So let's say that we wanted to declare products, or declare a product variable. So we do product p equals new product. Now this is an explicit variable declaration. We also can use the keyword var, and we can then say new product here. And now this is an inferred variable. And the difference here is that the keyword var basically tells the compiler, change the data type for P2 and make it be the same as whatever P2 is assigned to. So in this case, we're assigning P2 as a new product. So when the compiler evaluates this line, it will actually convert it into product P2 equals new product. So these two lines are essentially equivalent. So where's the value or the gains in using var versus being explicit? Well, there's a couple of potential gains. The first one is that if you end up at some point and you want to change this from product to, let's say, a product collection, then all you have to do is simply change the value on the right side of the equal sign, and all other adjustments take place automatically. Pretty nice. When you start to get into using LINQ queries, which we'll talk about in a moment, the LINQ queries often create, they can create dynamic collections, or they can create what are called anonymous types. And with an anonymous type, the compiler is actually responsible for declaring the type, and it gives it just kind of an abstract class name. It's strongly typed, but it's something that's kind of abstract by name. It's something the compiler makes up for you, and you don't really know what it is. So by using the keyword var, you're basically saying make P2 whatever P2 is being set to. So we can kind of go beyond that and show that in just a moment. Another use, or another case for using var, is for anonymous types. Now, an anonymous type is a variable or a type where it is just kind of created ad hocly, and you can make these anonymous types by simply saying var variable name. In this case, I'm calling it anonymous, and I'll say new. And just as we would do the inline initialization for a class, we can also say new, and then we'll just do open and close curly brackets, and inside of here we're going to actually define our names for our properties. So we can just make up any names. We can say ID equals 12, and then maybe we say something like student ID equals 1, 2, 3, 4, 5, first name equals Kevin, and last name equals Gantos. Now by doing this, what the compiler is going to do is it's going to say, okay, I need to create an anonymous type, or an anonymous class with a property of ID, a property of student ID, a property of first name, and a property of last name, and then set those properties to 12, 1, 2, 3, 4, 5, Kevin, and Gantos respectively. Because we don't have an actual type here, as we would in a traditional sense, where if we said var product equals new product, and then we put things like category soup, name chicken noodle, price 129. This is a inline product initialization. This is an anonymous type. So you have the actual class or type here after new. in this line on line 23, we don't actually have a type. It just says new, and then we have this collection of properties and values. Anonymous types consist of just properties and values. Anonymous types cannot have methods or events or private fields. So this is a great way of packaging up information that you need to maybe ship off to another place, or if you're working to build some sort of aggregate calculation, which again you'll see in a moment with LINQ, where you're wanting to pluck out particular values from a variable or from a collection and just store the small pieces that you need, or store calculated values that you need. You can do all of that with these anonymous types. And you'll see this a lot in MVC as we go through the process of creating what are called view models and being able to pull data from our classes or our actual implementation models and then generating what are called view models that we send off to our views. So these are anonymous types. LINQ, which was the next piece I wanted to really talk about, is this ability for you to query data using C#. Now, LINQ is a pretty powerful concept and a powerful tool within C# and within the .NET framework. And it was originally developed to facilitate the process of pulling data from a system, be it a database or a collection of objects, with the goal of being able to actually do what we would traditionally think of as writing SQL queries, but doing them in C#. So what I'm going to do is I'm going to create a LINQ collection. I'm actually taking this directly from the textbook, so that way we have a concrete example to kind of work against. And what this is it's a collection of products. Now, if we wanted to query out just the products that are water sports, for example, we can write a LINQ statement against products. Now, product, if you recall, this is our implementation for product. We originally did full declaration properties. We've now decided that we're going to do auto-implemented properties. So we have these properties for our class. Generally speaking, classes that just have public properties and not much else are often referred to as POCOs, or plain old CLR objects. The CLR is the compiler system that .NET uses. Stands for Common Language Runtime. So this POCO, this class that we have for product, is just a very simple class that contains not much more than just a series of properties for holding values. When we come to this collection or this array of products and we go products dot, you'll notice that we get this huge list of methods and some properties that we have that we can run against this array. And you may be looking at these and going, okay, well, these seem very unusual. There's a lot of them here. What's going on? Well, if you remember from us talking about extensions, you'll see a lot of these methods have the cube with the arrow, and these methods are extension methods, and they're extending what's referred to as IEnumerable generic. And just about any collection within the .NET framework, specifically arrays, lists, dictionaries, all have implementations of IEnumerable, which is an interface. And because of that, these extension methods are accessible to us to be able to write queries. Now, we have two ways of writing LINQ queries. We can write a LINQ query using the dot notation that we're very familiar with. So let's say we wanted to grab all the water sport products. We can say products.where, and then we're going to put in here a lambda expression that helps us identify which products we want. So we'll say P, where P is a product, and the category equals water sports. And this is case sensitive, so I need to make sure that's lowercase. And then what I'm going to do on the left-hand side is I'm going to say var water products. And the reason I'm using var is because I'm not really sure what the where is going to return to me. And frankly, it's not that important to me either. All I want to know is that I end up with a collection of water products. I can then do additional queries against that, or I can do water products dot to list, and that will give me a list of products. There's also things such as to array and to dictionary. So using these extension methods, we can do a lot of great things with LINQ. Now, I talked about being able to write queries and writing these queries so that they actually look kind of similar to SQL queries. So I'm going to go ahead and we'll actually just comment this whole line out. And what I'm going to go ahead and do is I want to, just so I don't end up with any variable collisions, I'll comment all that out. And then we're going to go ahead and do another var water products. And I'm going to do equals. And then I'm going to write what looks almost like SQL. So if you're familiar with the idea of, select all from products where category equals water sports, we're going to write something very similar to this. It will look a little different and almost upside down if you're familiar with that syntax. So to write a LINQ statement, we start with a from. So we say from P in products, and then we say where category, or I'm sorry, p.category equals water sports. And then finally we'll do select P. Now if you look at lines 35 through 38 and you compare them to what we've written on line 33, you'll see similarities. You'll notice that we have products, so we're pulling our information from products. The P represents that first half of our lambda expression. That's our local variable, if you want to think of it that way. That is then getting evaluated. So then we have from P, the product, in products, where the product.category equals water sports, which is the right-hand side of our lambda expression, select P, P being the product that we want. So we now have a collection of water products. So we can now say water products dot to list, which will then give us what is a list of product. But we can also go deeper than that. We can go through and we can actually use the LINQ statements in combination with the anonymous types and basically build our own kind of dynamic type that we want to use temporarily. So let's say var, let's see what would be a good example. Let's just say that we want to grab name and price. We don't care about category, we don't care about anything else. So we can say simple products equals from P and products where P dot price is less than 100. Select new, and I'm going to actually define an anonymous type. And what I'm going to say is P dot, I'll say ID equals P dot product ID, comma, name equals P dot name. Now if we come down here and we say list product new list equals simple products dot to list, we'll actually end up with a compiler error because the to list, if you can look at this, it basically is saying that it's attempting to take IEnumerable of tilde a and call to list. The tilde a is the simple name that the compiler gives this anonymous type. And since we said new list is of type list product, it cannot convert tilde a to list product. So what we'll do instead is we'll say var new list, and then we'll say new list, and just looking at the IntelliSense information, it says that new list is a list of a, or tilde a, of that anonymous type. It even says here anonymous types, tilde a is a new int ID string name. So from this anonymous type statement, it actually infers that ID is an int because product ID is an int, and that name is a string because P, or product name, is a string. So there's a lot of inference that goes on within the use of these anonymous types and type inference. And it's there for a few reasons. It's there to facilitate faster coding, but it's also there to provide you with the capacity of creating code that is still strongly typed, but can be flexible enough for you to do dynamic allocations and dynamic, or not dynamic, but anonymous type creation, so that you're not having to declare additional classes for one-off situations. Now, one thing that I will tell you is that anonymous types specifically cannot be passed between the boundaries of a method. So you can't create an anonymous type collection and then pass it as a parameter to another method. It does not facilitate that unless you pass it as an object, and then there's a lot of under the hood mechanics using reflection that you can use to make that work. But generally speaking, you can't say I'm going to pass this anonymous type or this collection of anonymous types into another method. It just doesn't work that way, because these anonymous types are kind of use and throw away classes. They're not things that you would want to persist and use over a long period of time. Alright, so that's basically the covering of type inference, anonymous types, and LINQ queries. So these functions of the language are key pieces to facilitating the use of an MVC application and creating the components and mechanics that you would need. Now, the last thing that I do want to share is I want to go ahead and actually launch this application. I'm going to uncomment this collections of extensions, and I'm going to put a breakpoint here, and then I've got a breakpoint set down here. And what I want to show you is how this extension method executes. So in the previous video, we built an extension method for our shopping cart, and we created a method called getTotal. GetTotal takes the cart and then has a product selector function pointer that is called to deduce whether or not the product should be included in the total price. The product selector is this lambda expression of p.category equals fruit. So I want to just run through this with you so that you can see how all of this works. So I'll go ahead and hit start. So we'll run the collections and extensions method, which is the collection of code that was written in the first half of this video. And we'll just step through here. Just in case you're not familiar with the debugger, I want to just remind you. So I hit start to start debugging. I've set these breakpoints in my code clicking on the left-hand margin. So that puts a breakpoint on a given line. And then you have 4 basic navigation buttons that you use when debugging. You have the arrow, which is the show next statement. So this statement that's highlighted right now is the next statement to be evaluated. So shopping cart equals new shopping cart has not actually run yet. So if you mouse over cart, you'll notice that it's null. If we do what's called a step over, we'll step over this line, not skipping it, but stepping to the next line. So this line will then execute, and we step into the next line. So now cart is a new instance of shopping cart. It actually has one property, which is a collection of items. These items collection is a collection of products. So we now have a cart, and then we can evaluate these lines. So step over steps over to the next line, steps over to the next line, over next line, next line. We now will stop on this line with a breakpoint, and we're going to actually use the step into button, and what this will do is it will allow us to step into any method that is being called. So decimal price equals 0 right now, but we're going to call cart.getTotal, getTotal being the extension method, and we're going to look at how this lambda expression comes into play. So we're now inside of the extension method because I stepped into that line. So we're now executing this method. So I'm going to mouse over cart, and you'll see that that is our shopping cart, and I'm going to mouse over product selector, and you'll see that it says that it's a method that returns a boolean that came from collections and extensions, and it defines all the functions of this lambda expression. So I'm going to go ahead and step over into my for loop, and I'm going to step to this if statement. So what it's saying now is product selector P equals true. So it's looking for when the product selector returns true. So P is one of the products out of the cart from cart.items. I'm then going to step into product selector, which will bring us back to program.cs, which brings us into the right-hand side of the lambda expression. So this P is the cheese product that was over here as P in our extension. So you see how the code kind of weaves back and forth a little bit. So this is that cheese product. I'm going to step out of this line, which will bring us back into the extension method, get total. P is that same dairy cheese item. And we'll go ahead and step over. This evaluates to false because it's not fruit, so it skips it. I'm going to do a step over again, which will bring us back into the loop for the next item. We now have a new item in P, dairy cheese again. Well, we added that item twice, so we have 2 of them. There's a total of 5 items. 2 of them are dairy cheese. 3 of them are dairy cheese, and 2 of them is the fruit or apple. So if we step in again, it'll say that this is still dairy. I'll step out. I'm going to actually go ahead and click to add a breakpoint here. I'll hit continue. It'll iterate the loop one more time. P is still dairy. I'll go ahead and hit continue again. And P is now fruit. So I will step in. P.category is fruit, so fruit equals fruit. That's a true statement. If I step out, I'm now back at the shopping cart extension. I'll step over, which will bring me into the if statement because product selector for that fruit item evaluated to true. So that price total now is total price is 0, and then we'll do a plus equals of 99 cents, which will bring our total price now up to 99 cents. I'll just go ahead and hit continue again. We'll evaluate the last product. I'm just going to hit continue, and we'll get to total price. Total price reflects $1.98, and there are 2 fruit items in the cart, which at 99 cents a piece equals $1.98. I kind of went through that a little quickly. I would recommend downloading this and putting some breakpoints in and using these step over, step into, step out for yourself, just to get familiar with kind of controlling the flow of your application and watching how your program executes. It's vitally important as you go through debugging your program, especially when it gets very sophisticated, to be able to understand what the program is doing and in what order. The order's not always as obvious as you think. Sometimes you have these moments where things weave in and out from one another when you start to have reference pointers to functions and things like that. So I highly recommend, if nothing else, download this project once you're done with the tutorial and just set some breakpoints and walk through the code yourself and see what's happening, because it's very interesting how these pieces interact and play with each other. Alright, so that is the second half of this lecture. If you have any questions, as always, feel free to put those into the discussion board or email me directly. If you have anything else regarding the final project, please feel free to ask that as well. Hope everybody has a great week, and thank you very much.